Right, in this lesson, we are solving systems using the method of elimination. And so I'm just going to skip to some examples of elimination. With elimination, you have to make sure that your x's are lined up, your y's are lined up, your equal signs are lined up, and your constants are lined up. Once you have that set up, you are ready to add your equations, okay? And so when I add 6x and negative 3x, I get 3x. When I add negative 4y plus 4y, they cancel each other out to 0. And so we're not going to write the 0. We want to keep it simple. Then we have our equal sign, and then 14 plus 1 is 15. And so because the y is canceled out, I have this easy one-step equation I can solve for x, and I get x equals 5. Okay, and so once you have one variable is eliminated, you are able to solve for one variable. All you have to do after that is go back to your system and pick either equation to solve for the y. And so I'm going to use this equation, negative 3x plus 4y equals 1, but now we know x is 5. So I can substitute that value for the x and then simplify. So negative 15 plus 4y equals 1. We would then add 15 to both sides to get 4y equals 16. Divide both sides by 4, and we get y equals 4. So my solution is the ordered pair 5, 4. Okay, and so with elimination, one of your variables gets eliminated when you add the equations together. Okay, and so for this next example, I have my x's lined up, I have my y's lined up, and I have my constants lined up, and of course the equal sign. And so when I add them together, 5x and negative 5x cancel each other out, gets eliminated. For my y term, I'm left with negative 4y, and then my constant equals 12. Divide both sides by negative 4, and we get y equals negative 3. Okay, so this time we found y first. Now we can pick either equation. I'm going with the top one, 5x plus 2y equals 4, but now we know y is negative 3. And so that simplifies to 5x minus 6 equals 4. We could then add 6 to both sides to get 5x equals 10. Divide both sides by 5, and we get x equals 2. And so our solution is the ordered pair 2, negative 3. Now, these two examples were set up very nicely for one of the variables to get eliminated because we have what is called a zero pair. When they have the same coefficient but opposite signs, they add to 0. Okay, and here we had a 0 pair in the y's. If we don't have that set up, we can rearrange and even scale our equation. So we could rearrange, we can multiply by a negative 1, or we can even multiply one or both equations by a factor to get a 0 pair. Okay, and so let's look at some of these examples. So your first step in any of these situations is to rearrange both equations to standard form, both, so that your x's, your y's, and your constants are lined up. And then we create our 0 pair coefficient, we add the two equations together, and then solve for the remaining variable. Okay, and so looking at number 1, my x's are lined up, my y's are lined up, my constants are lined up, but we don't have a 0 product or a 0 pair. But if you look at the y's, those are close to being the same. We just need to change the sign of one of them. And so what you can do is you can scale the entire equation by a -1. This is only legal if you do it to all 3 places. And so that new equation would be -6x plus y equals -7. Now, when I put the other equation below it, now I have my 0 pair. Okay, and so you can multiply either equation by a -1 to make this happen. I just picked the bottom. And so now the y's will cancel. I'm left with -11x equals -11, which means x equals +1. I'm going to use this bottom equation, the original 6x minus y equals 7, but now we know x is 1. We just found x was 1. And so that becomes 6 minus y equals 7. I subtract the 6 from both sides. So I get -y, which is technically -1y equals 1. Divide both sides by -1, and we get y equals -1. Okay, and so x is 1, y is -1. My solution is 1, -1. Okay, looking at let's look at number 3. Here, my x's aren't a 0 pair, my y's are not a 0 pair. And so what we can do is, let's focus on the y's. You can pick either one. But look at how we have a -2. If I had a 2 right here, I would have a 0 pair. But I can't just put the 2 there. I have to do it to the entire equation. So I'm multiplying the entire bottom equation by 2. And so I'm going to copy down the top equation just as it is. And then I'll copy down the new second equation, -4x plus 2y equals -10, all 3 places. So now when I add them together, my y's create a 0 pair. So those cancel out, leaving me with 2x equals -8. Divide both sides by 2. We get x equals -4. Okay, from there, go back to your original system. Pick your favorite equation. I'm going to use this top one. 6x minus 2y equals 2. But now we know that x is -4. So that gives me -24 minus 2y equals 2. I can now add 24 to both sides, giving me -2y equals 26. Divide both sides by -2, and we get y equals -13. So x is -4, y is -13. My solution is -4, -13. All right, the last examples I want to do are 6 and 7. When you look at 6, we already have a 0 pair, but it's in both the x's and the y's. So I'm left with a 0 equals, and then on the other side, 10 and -10 also gives me 0. And so whenever you have 0 equals 0, that is true. This means you were dealing with the exact same line. And so this would be infinitely many solutions. Okay, not all real numbers, infinitely many solutions, because our solutions are ordered pairs. Each solution is an ordered pair. Okay, for number 7, we have the same situation. The x's cancel, and so do the y's, leaving me with 0. But on the right side, I end up with 20. This is not true. Okay, so this would be a situation where we had parallel lines, and so we would say no solution. Okay, parallel lines have no solutions. And you'll be left with a false statement. If you have a true statement, that means you were dealing with the same line, and it would be infinitely many solutions.